Hello, everybody. Welcome to this session of the Human and Planet Initiative titled Human, Planet, Data and Knowledge for GEO, Decision Makers and Scientists. I understand there's a huge competition, and thank you for joining in selecting our session. My name is Daniele Ehrlich. I'm a part of the Joint Research Center. Previous slide, please. The introduction. Yes, the session is organized in the following way. I will briefly introduce the session and provide my first presentation on highlights of the Human Planet Initiative and Outreach. Then Martino Pesaresi, that is a co-lead of the Human and Planet Initiative, will provide an insight of the datasets that will be released soon. Monica Kuffer from University of Twente will provide her work on urban areas and slums within the two important projects, IDEA Maps and Slump. And finally, Dr. Robert Chen from Season will provide a potential and future directions and services. So you are welcome to provide questions in the Q&A sessions. The speakers will remain on video. Those that they're remaining will switch off the video just to facilitate the transfer of information to the internet within this AirMet in order to avoid any disruption. So next slide, please. So my name is Daniele Ehrlich. I'm about 10 years of experience in crisis management, and about 8 years have been working with Martino on mapping human settlement globally. I'm part of the GEO Disaster Risk Working Group, and within the Human Planet Initiative, I have to coordinate the activities. Next slide, please. So I wanted just to provide you an overview for those that are new to the Human and Planet Initiative. So the initiative is co-led by the European Commission Joint Research Center and the Center for International Earth Systems Information Network, located at the University of Columbia. And the two colleagues are Martino Pesaresi and Robert Chen. We are part of our bigger consortiums, and I am able only to show you the logos of the organization that contribute to the Human Planet Initiative. The main objectives of the initiative is to map human presence, understand hazard impact on societies, also understand the demand of resources and sustainability, and there is a new trend on understanding the human dimension of global environmental change. Next slide. So the two, I would just one slide just to tell you the important that's one of the big data sets. The most used data sets are, for example, the GPW data from Season, one of the important data sets that everybody that works with gridded population uses. GPW is also used for the socio-economic pathways used within IPCC. On the left side, we have the global human settlement layers. We have the built-up population and the settlement model. The built-up is the creation of, under the direction of Martino, that has developed global maps for different decades. The population grids are a co-production between Season and the GRC. And finally, the settlement model is a co-production with decision makers that have requested this data set. Just to mention that these data sets are also part of the EO for SDG project that is now running a session in parallel to this one. Some of these data sets are also part of the GEO Knowledge Hub and will be probably part also of the EO Toolkit for Disaster Risk Reduction. Next slide. So I wanted just to provide you also information of 3 important projects funded by NASA. One is already running for some time, which is the PopGrid collaborative, managed by Season. And this project, among many things, also includes a viewer, which I show on the slide, that's able to compare population grids from different sources. And not only you are able to understand the differences in the population grids, you are also able to extract population statistics from these grids. And this is to help decision makers to decide which population grid to use based on what the application is. I'm showing also here the COVID viewer from Season. That is another highlights of this recent 2 years, and that provides population totals, but also grid population by age group and by gender. Next slide. Another new project, NASA-funded project that contributes to the Human Planet Initiative is the Black Marbles, the night lights data that are now collected over the globe. And this is a very important data set for mapping for a number of applications, which fits very well the Human and Planet Initiative objectives, because the data have been used for crisis management, conflict area identification, and for electrification mapping, for urban mapping, and so on. And I feel that the strength of these data sets will be exploited when we combine this data with the other data sets from the Human and Planet Initiative. Next one, please. The third project funded by NASA is the Missing Million project, which addresses the mapping of refugee camps across the globe. That's a very important and difficult task, because refugee camps are often made up with very poor material that often is also can be confused with the background landscape. So it's very difficult to detect. Well, this project tries to map these refugee camps and will complement the population grid data, the other population grid data generated from the Human and Planet Initiative. Next one. And I wanted just to provide you also a few highlights from the work of the Human and Planet Initiative are listed in the Human and Planet Atlas 2021, and which provides a number of examples of how practitioners use the Human and Planet Initiative data. On the right, there is also a graphics that illustrates part of a paper that lists 50 scientific papers outside of the Human Planet Initiative, or part outside the Human Planet Initiative, that address scientific issues using Human Planet Initiative data. Some of this data of the scientific work then is also used to report on the international framework agreements. Please, next slide. In fact, the Human and Planet Initiative datasets are being used for addressing all four engagement priorities from the GEO program. The new urban agenda has been just added, I understand, as of today or recently. So the Human Planet Initiative is used to address, for example, SDG 11, so sustainable for the sustainable development goals. They are used also as exposure in understanding disaster risk, and this was one of the first applications. Inevitably, as we are mapping urban areas, it is addressing the new urban agenda. And very important now, we feel that the data are used not only to address disaster risk related to climate change, but also for the new global stock take of the Paris Agreement. The data are used also for other policy institutions. For example, we are OECD is using it, and also for scientific issues like planetary boundaries. Next. Within GEO, this is just, I don't go into detail, just to say that we are very present in those projects that address crisis management. We are present in the capacity building through EO for SDGs, and also in regional activities like GEO Mountain, and we have worked in the Arctic, even if we are not part of the GEO Arctic yet. And I feel there are lots of potential to link with many other GEO projects. Next. And just to say that lots of our knowledge is contained in the atlases. I list here the cover of the atlases, and all the material is available through the websites from CESN and JRC. And we have two new other events in this the GEO Week 2021, one tomorrow organized by Blue Planet, and then two regarding the disaster risk toolkit, one at 6 o'clock tomorrow evening, and that will be repeated at 11 o'clock on Friday. And with that, I conclude my presentation, and I would like to go to the next speaker. And please, you introduce yourself. Thank you. The floor is yours, Martino.
Thank you, Daniele. So, my name is Martino Pesaresi. I work at the European Commission, Joint Research Center. That's my bio. Yeah, that's my picture. Nice picture. But it's yes, it's several years that I work in remote sensing domain, but also in the system for support to the public decision, support to the decision and policies. I was initialized the global human settlement layer idea, concept, and project some years ago in 2014. And now I'm happy to co-chair the Human Planet Initiative together with Bob Chen of CESN. Yeah, next slide. I opened the presentation, say that the open public data is augmenting because there is an accelerating technology development ongoing that was already foreseen some years ago, but now we are living that moment. There are new satellite data sensors that are also available as public open data. New voluntary geographical data like OpenStreetMap is now reaching a mass that is considerable as respect to 10 years ago and more when they were starting. There are new data analytical frameworks, new computational infrastructures. The cost is lowering down. So the I think important question is that all this is bringing new information and new decisions. That's where we as GHSL, we try to make value added. So that's a slide. It's about what are the requirements according to our understanding for actionable metrics. So metrics or measurements that should make an action, in particular a public action. So that's as peculiar characteristics. So according to us, those should be universal open data. Anybody should see the same numbers. Human understandable methods. So we should be convincing about how we extract information and understanding out of the data. The measure should be repeatable, so as much as possible, not based on random understanding, but should be repeatable. Each time we take the same measure, we should get the same number. Seems a stupidity point, but not so stupid when you have a complex system behind. And also the metrics should help to pass from monitoring to understanding, because it's the understanding that drives the action, especially the public action. So, for example, the data should help causally the understanding of causal interlinkages And so we should, for example, have a temporally consistent trends and prediction. So allowing to make a prediction based on temporally consistent trends. Also, this maybe seems very obvious, but if technological development is producing different sensors, these different remote sensors fly on the sky, and then you change the methods to process the data from the sensor to thematic information, then very probable your thematic change is including also a noise that is coming because you are changing the sensor and changing the method. So it's a big problem to be consistent in temporary trends, but then going maximal possible depth in the past observation to basically extend as much as possible your observation window. That's the challenge that we are trying to address technically in the GHSL approach. Next slide. So that's the list of improvement that were making us busy in the past 1 or 2 years. So basically, we were trying to improve the thematic precisions, the precision of the new data respect to the old. This is because we have a new Sentinel imagery in the background that is 10 meter resolution. The previous data was open data was based on the thematic mapper platform of the Landsat, so 30 meter resolution. If you go from 10 to 30 or from 30 to 10, you have basically 9 times more dense sampling. That's the level of the discussion. So we were increasing by 9 the amount of points to describe the landmass surface. Also, another improvement is that we are passing from the built-up Boolean class. Basically, we were answering to the question, is that pixel 30 by 30 meter built up or not? That was the question. Now we are passing to a more complicated question to answer. So this 10 by 10 meter resolution pixel, what is the fraction of this pixel that is covered by a roof in a building? That's a bit more complicated. So we are trying to make the answer a bit more precise. And also important, we are trying to, assess in a better way the scattered rural areas, especially in poor areas that are data poor, but also complicated to collect in terms of built-up areas. Then another important point, as I was introducing before, is to improve the thematic consistency versus the historical sensor change. Of course, we cannot avoid that we have historical sensor change. The sensors in the 70s are very different than the sensor we have now today. Just to compare a TV screen you have now versus the TV screen of your parents when you were looking at the TV in the 70s, if you were born at that time. Anyway, that's the difference. So it's a huge difference technically. And we try to cope with this problem by, for example, again, having a beta fraction estimates instead of a Boolean. The Boolean estimate is much more sensitive to the change of sensor. And also, we establish a new segment-based change detection workflow, while before we were going by pixel. But maybe this is too technical. Anyway, I'm very happy to discuss about that if there are people interested in that. Anyway, it's a new framework. And also, the third point important is that we try to improve the information support, in particular for population grid downscaling from census data. That's one of our core business. And this is done by trying to propose for the first time a classification of residential built-up surface versus not residential, so including industrial or commercial large buildings that not belonging to the residential class. Next slide. That's an example of one city. We are in Zambia, Lusaka. That is the previous assessment of built-up areas. So what you see as a dark color, it's the Boolean class built up, yes. It's a 30-meter resolution data, and as I said, it was based on open and free data coming from the Landsat program at 30-meter resolution in this case. If you go to the next slide, you see what we are getting with the new data. We are in the same place. Instead to have a Boolean classification of 30-meter resolution data, in this case we have a 10-meter resolution continuous class assessment. So is what we call built-up fraction. You see that in this slide we have much more heterogeneity than in the other. For example, we see those bright areas are areas with a hyper dense situation in terms of built-up surfaces. If you switch on the previous slide, you see that this information is not present in the other data. So the other data was less heterogeneous in describe the inner part of the city. If you keep switching up and down, you will also observe that in rural areas, for example, in the fringes of this city and also in the rural areas, we are collecting much more information than before. So we were trying to basically reduce the omission error that was created by the fact that the methodology was less performant, but also the sensor was not able to distinguish the background from the foreground information. Now we have a better solution, so we are improving a bit. Next slide, please. This is also in the same place, another important message. As I said, we are describing the inner, we are starting to describe the inner side of the built environment. So it's not anymore a Boolean mask. Now we can talk about characteristics, inner characteristics of those built area. And in this case, for example, we see the difference. The brown blobs are the residential areas, while these pink or magenta are the built-up surface that we associate to the not residential, so the industrial or commercial areas. You see also some green, etc. This is information coming from the radiometric property of the reflecting surfaces. So we understand that in those samples, for example, there are more or less green component. So in very short, the point is that now, and this was not possible before, we can describe the inner characteristic of the settlements with a precision that before was not achievable. So next slide. This is a zoom about density. The picture here is a VHR imageries from Bing. I'm zooming in Lusaka. If you go to the next slide, you will see what is the response of the model at 10-meter resolution, talking about the density of built-up surface. This is coming from Sentinel-2 input images, so open and free. We can calculate in any part of the globe, anytime, etc. So it's a proxy, of course, of data 50 centimeter resolution, but has the advantage that it's open and free. You can exchange, and it's very much suitable for scientific use. So next slide. That's another picture coming. I think we are here. Yes, in Johannesburg. You see also here that we are talking about the inner characteristic of the built space. You see the brown areas now correspond, for example, to Soweto and other known township. Those areas are areas that are connoted by the fact that it's higher the density respect to the inner core of this city, for example, where we have more rich people living, so they have a garden, they have houses with more space. This is something that it's basically linking the physical characteristics of the settlements with the living conditions, and then, for example, in this case, to social divide in that specific city. So that's again a hit on the probably next year's work using this data. This is go next slide. Yes, thank you, Paola. Yes, that's the same data, but we are somewhere else. Here we are in the border between US in the north and Mexico in the south. So you can see, because we describe the inner characteristics of the built surface, now you clearly see the different cultural but also social characteristics of people living up and down. We are in the same geographical place here. That's the story. But the settlement pattern that the different communities are built in the two sides of this river are very different from the physical point of view. So, of course, this will then downstream might generate several important assessments from this data. Next slide. This is the quasi last slide that is talking about the characteristic of new GHSL data on built-up surfaces. It's a summary. So the definition of the built-up class abstraction, we keep constant. So we are not changing mind on what we mean for built-up. It's any roofed built structure above ground for any use. That's it. So that's what we call built-up surface. Before we were measuring this at 30-meter solution. Now we are measuring this at 10-meter solution. Before it was a Boolean class, yes and no. Now it's a continuous estimation going from 0 to 1. The residential versus not residential class before was not available. Now it's a Boolean class, it's a Boolean mask. The observed epochs before were 4, 75, 90, 2000, 2014. In the new release will be 5 observed epochs, 75, 90, 2000, 2014, and 2018. The change map before was pixel-based, so sensitive to the change of the sensor. Now we are segment-based change detection, so we are more robust against the change of the sensor. The spatial resolution of the generalized
excuse me. Sorry for interrupting. I think you have to start to close down. I'm sure you can elaborate this in a questions session.
No, it's just one slide, Daniele. Yeah. So thanks. Let me finish. It's 250 meter versus 100 meter of the aggregated session, of the aggregated grids. If you go to the next slide, that is the last, you will see how those innovations are then taken into account in the population grids that are, let's say, using the new built-up surfaces. And then next slides. I thank you very much for attending, and I hope this was an interesting part. Thank you very much.
Please, Monica.
Daniele, you are muted.
Yeah, I apologize. Thank you, Martina, very much. And Monica, please go ahead and deliver your presentation. The floor is yours. Thank you.
Thanks a lot, Daniele. I'm Monica Kuffer from ITC University of Twente, and I will talk about Earth observation data in 2 projects, which is Idea Maps and Slum Map, both focusing on area which you normally know as slums, informal settlements, and we typically refer to them as deprived urban areas. I'll explain you also a bit about the context. Could you please go to the next slide? So it's a long text. So I'm Monica, and I'm working for many years on Earth observation and in general geospatial models, looking to relatively the complex cities on this planet, the cities which located what I normally now call in low and mid-income country cities, which are the poorer part of the cities, which have often very complex dynamics, also very complex morphologies, and I'm involved in several ongoing projects on mapping. Next, please. So what we see is that globally, we see an enormous increase of urbanization rates, and a majority of this increase will happening in low and mid-income country cities. And in areas which you see on these photos, which are the deprived urban areas. So these areas are typically deprived in terms of services, infrastructure, housing condition, and also environmental conditions, and are often having systematic omissions in in open and public available data sets, often being not well captured or totally underrepresented, also before referring to population models. So you see often such areas are captured only with a small share, sometimes only 10% of the population is really recorded in globally available population models because of the complexity of modeling this very densely and congested build-up areas. Next, please. So within idea maps, we have been combining very different mapping tradition and also capacities of people coming from the side I'm coming, which are the more Earth observation-based modelers, looking to developing methods of mapping and capturing urban spaces with Earth observation data or geospatial data. But we see really the importance of linking in particularly to community-based mappers and modelers to integrate Earth observation-based models with data which you normally now refer to citizen science methods and community-based data collection. Really to have this two sides and this integration of models and data collection. Please, next. So within idea maps, we have been defining this conceptual framework, which we call the domains of deprivation. So there are in total 9 domains, which are listed here, for example, physical hazard assets, which are categorized at 3 scales. So the household level, the within area level, and the connect area level, how areas are connected with the rest of the city. And this framework allows to develop indicators, and this indicator are partially able to come from Earth observation data, and other indicators are coming from open geospatial data sets. And we want to capture deprivation as a phenomena which is sort of on one side a household concept, which is typically slums, a household level concept, but adding also the area level of deprivation, how an area is deprived in terms of access to services, but also environmental conditions. What this conceptual framework allows, and that's what we're also working on, we are using gridded mapping systems to capture city-level deprivation map, also in terms of a continuous scale, not only pinpointing to the typical slums in form of a binary map, but seeing it as a continuous surface from the most to the least deprived areas of a city. Such data can be locally meaningful and by local users, of course, also categorized into binary products. If, for example, slum versus non-slum maps are required and then in the end overlaid with existing population data or models to estimate, for example, the slum population, which is required for SDG 1111 monitoring. Next, please. So what we are planning in future, as we have been doing these pilots for several African cities, we are planning to scale this method up to a sample of further cities across Africa and also having a balanced sample of different city sizes. And we are using a database from our colleagues from GRC, the Urban Center database, which allows us to produce such sample. And basically then also towards the vision of how can we generate massive amount of data at scale, looking within another project within SlumMap to the affordability question. So the use of not typically the very high resolution, costly Earth observation products, but to see how far we can come with free or low cost data like Sentinel-2 data on a free option or spot data as a low cost option for producing Earth observation-based models. Next, please. So this is one of the outputs of my colleagues from ULB within SlumMap, comparing the mapping accuracy from, on the left side, you see Sentinel-1 and 2 combined with auxiliary data, mapping output of the city of Nairobi, showing the percentage of deprived of a cell. So we use gridded mapping systems, also not to show exact boundaries, because we also acknowledge issues of ethics and privacy, not wanting to contribute to stigmatization of areas. So these maps are now comparing. On the right side, you see the spot-based image, and you see that Sentinel is providing a quite good mapping accuracy. Next, please. So beyond the location of deprived urban areas, we also look to characterization, like the mapping of the waste piles. And I think I've seen my colleague Stefan, who is in the session, who produced this map showing the waste density. Waste is an enormous environmental problem across deprived urban areas. It leads to enormous health issues, particularly if floods are occurring. The whole waste is flooding through the area. And you see also that the density of the waste accumulation is following the drainage system. And we can produce such maps rapidly with Earth observation system to show the presence of waste accumulation in settlements. Next, please. Another aspect, we are looking into the urban morphology and also describing from information we can extract from high-resolution images of the building footprints, which are extracted with deep learning, and training morphological-based models to capturing different urban types, which allows us to categorize and also understanding the diversity of deprivation. For example, atypical slums versus typical slum, low-cost housing areas versus other urban forms and other residential areas in a clustering process. Next, please. So finally, I would like to, if you're interested in the work, invite you to visit the websites of Idea Maps, which have a long documentation, very detailed documentation with a target of local governments to help generating, based on geospatial and open Earth observation data, gridded deprivation maps and a clear documentation of all the steps. Or within Slum Map, also to look into the question on how aspects of environment, like the case study of waste accumulation in communities, with also some nice videos from the community groups we are working with, are helping and can be connected with Earth observation systems. Next, please. So I would like to thank you and looking forward to your questions.
Thank you, Monica, very much. I think very encouraging to see your results. For the sake of time, I just we should continue to the next presenter. So please, Bob, your floor is yours.
Great, thanks, Daniela. Glad to be here, and I knew I was last, so I'm going to try to keep this pretty straightforward. I have no graphics. Next slide. As was mentioned, I do co-chair Human Planet with Martino, and have enjoyed working with JRC and Monica and others. I am on the delegation of the Sustainable Development Solutions Network, and I do work on Human Planet projects with NASA, coordinating some of the projects you've already heard about. Thanks. Next. So again, I'm not going to review things you've heard about. Most of the points, these are some of the major items in the current GEO work plan that we're dealing with, and Danielle and others have already gone through them. I did want to emphasize that as you heard, we do try to work with other GEO initiatives. We've done a lot with EO for SDGs and a few others. I think one new thing is the second bullet about annual updates to the GHSL data. That's something that is new, and my colleagues at GRC can say more about that if there are questions. Next. So since I was talking about, asked to talk about potential future directions, I was thinking of three main questions. And again, we're still just starting to think about the next work plan, so none of this has really been fully vetted with the group. So it's really my opinions on this and what I've kind of informally been discussing. But the three questions are, so if we think about the human planet, and we mostly talk about population and settlements, but there are other areas that need attention and need data that's open and more consistent and of course more detailed and informative. Secondly, can we make the data we have more accessible? And I separated out a third question, which is how do we make it more useful and trustworthy for users? So next slide. Here's just a kind of an initial list. It's open. We're looking for people to either want to help with these or even add others. But clearly, we could do more, as Martino puts it, with the inside characteristics of built infrastructure, but moving beyond even slums to different kinds of and characteristics of infrastructure and critical infrastructure, more about how people are using land and where they are, when, and so forth. There's always a difficult issue of understanding all the different kinds of administrative boundaries. Sometimes you can see them from space, but more often it's buried in documents and GIS files, and it varies. It's not just the political boundaries, but there are other important administrative boundaries that are needed to really convert data into decision-focused results that people in those bodies or areas can deal with. We've heard a little bit, of course, about the vulnerability issues. There's also the issue of movement of population. We need to think about, how mobile people are on different timescales, and to be able then to do change detection and monitoring of all of these things is obviously an important goal that would be useful across engagement areas. Next. Getting to that is how do we make these data more accessible? They're obviously growing in volume. As you saw, there are many different sources of data using different models, including both public and private sector sources. So things are moving to the cloud. We need to think about how to integrate these analysis and visualization services, make them directly available to machines, to external portals and query tools. And so part of that, of course, is to work with the other GEO initiatives and flagships and tools to, build in those interfaces and links. Since we're talking about many different disciplines, what are the cross-sector and cross-disciplinary metadata and documentation issues that come out of that? Next. And then again, the trust and utility, one big issue is, how valid is the data? Do we have good assessments of uncertainty, and can we tell when a particular data set's better for a particular purpose than others because of the way the models developed and the level of validation and so forth? So we need to think about how to share validation data sources and approaches, and potentially do some coordinated experiments so people get confidence in the kinds of data that is being produced, and get better at showing people what the uncertainties are and the limits and strengths of the data. And that, of course, means in interactions with stakeholders and as well as other parts of GEO to build trust and document the utility of the data. And I think that's it. Next. So again, part of the objective of this session was to encourage people to give us input and see if there are areas that we haven't thought about, because we'll be formulating our plans for the next GEO work program period. And I think there's a lot of potential things we could do as we move ahead. Thanks.
Thank you, Bob, very much for putting on the stage for bringing up the ideas for discussion. If the audience wants to provide questions or comments on to the single presenters or to provide in general their hands, we can give you the floor. Maybe I want to just maybe Monica and Martino, maybe they want maybe to comment on the slides of Bob, maybe just to have their thoughts on accessibility, what other features would you like can be produced, and what features would you like to have for data sets? Maybe we can start with Monica, maybe. Oh, okay. And then we have a question. Yeah.
Yes, I think it would be great indeed to capture on what we're also working for to capture aspects of socioeconomic conditions on data sets, which is of course a very tricky question to model with Earth observation data, socioeconomic conditions. And you would need to make, possibly also to combine, that's also what we do with an idea maps, that we combine Earth observation data with existing geospatial data, really to understand variation, but also this understanding of the need of understanding how diverse urban areas are and how quickly it transform, and also data which really need to feed into to other data or other modeling aspects. I always get really excited about from my colleagues from the hazard domain looking to this predictive aid. I don't know if you ever heard this, like this idea of allocating funds before a hazard occurs. But if you feed it with a lot of the existing data models, the people most in need, the most vulnerable people, they're often not captured in global data set well, which might lead to an even more systematic omission of their needs. And therefore, we need really to look into socioeconomic condition variabilities, and maybe even leaving the urban areas, looking also into other spaces, not only the urban, but also the at least the urbanizing areas, because they are tremendously growing in many parts of the world, like in India, this sort of urbanizing zones are massively transforming.
Yeah, thank you. Thank you. There is also one question on the floor. I think it's also for Monica. And the question is, can we think about improving terminology to be more equitable, use an alternative to slum?
Yes, it's something which I typically, I use it because it's the most common term. Slum, other term is informal settlements, but they all have a very different corner, and therefore we talk about deprived urban areas, because it's a more, at least it shows that a place is deprived of something, and you can characterize what it is deprived of, maybe in terms of services, in terms of environmental condition, and it looks also to this more holistic understanding what is lacking. Of course, there might be other terms, but at least in also the discussion we have with local community groups, they feel much happier to talk about deprived communities as a slum community, because it brings a whole stigmatization into it.
Yeah, thank you. Martino, Bob, do you want to comment on this?
Maybe I would like to comment that the list of Bob are very long and interesting. And of course, it's a big challenge to fit there. We're just doing small steps. For example, in the long list of Bob, there was something about land use. Now we are just stepping in and try to at least discriminate between residential and industrial or commercial. But of course, it's very rudimental. Okay, better than nothing, but I think there is a large path of research that we should start there. And also, I would say that in the that's about remote sensing, so how we can extract information from data. Then, if we downgrade this question to how we can extract information from open and free data, that is another class of problem. I think we should understand if this is. I am in law with the GEO approach of open and free data. So for me, there is no discussion. But of course, we should be aware that open and free data is also a severe limitation, especially if you want to go in small, in detailed scale in information gathering. So there is a trade-off, and also, so maybe we might think to have try to help to mobilize resources to maybe get something that it's more refined data that maybe in a sampling approach we might try to describe reality in this way. So of course, if you need wall-to-wall coverage, you need open and free data, but maybe some scientific tasks like sampling or try to approach the reality from a sampling approach maybe can be solved by other kind of data, but that's a question mark. Yes, then yeah, that's all. But I think the fact that we will describe the density of buildings, that again is very rudimental. It's just surface density is the amount of roof you have in the square pixel. So very rudimental information, but still I think will be better than nothing. So my hope is that the model of Monica might benefit out of this continuous information that is not saturated in dense urban areas, but shows different sub areas inside. So different parts of the city. The big point question mark is this is still 2D density. Of course, for urban modeling, we would need also for population downscaling or many purposes, we would need the volumetric estimation of cities. And this is one of the limitations of open and free data. So far, we are not able to find a way to extract this information from open and free data in a computationally sustainable way. We are getting there. There is a community of people working on that side. So I'm confident in the next few years we might have in our hands a methodology to estimate also the volume of the cities using open data, because of course if you fly with a LiDAR and 20 centimeter data, that's easy, or easy, let's say, relatively easy, but it's very expensive, so you cannot escalate to globe. But this is a direction that I think also Robert would agree, it's a strategic direction for study of settlements, so the vertical dimension.
Thank you, Martino. I think thank you very much. I think we still have a few questions, and one is kind of difficult. It says, can you speak about environmental justice and climate justice considerations within the Human Planet Initiative? Anybody wants to take that one?
But we can always speak about everything, including the environmental justice. But Robert, go on.
Well, no, actually, Nancy hears from me about this a lot, so go ahead and answer if you have thoughts.
Yeah, I can only, of course, see it from my angle, and that's basically the angle which was also stressed recently at the World Cities Day, to say that the amount of money available for climate adaptation, I think about only 5% is going into the urban poor in the low and middle income countries. So basically, there's a huge question on how to prepare the areas which are most vulnerable to climate change impacts. Typically, when you look into the sort of city and you find the deprived urban areas, where the urban poor live, they are typically always found in the most hazardous zones. And typically, there's no attention going into how to prepare those areas for future climate change. You see that, of course, events are increasing, flooding increasing, and only this example of waste. And I think you don't understand the scale. Like, you have like human waste, which is basically of what is called flying toilets. And if a flood happens, this whole waste is flooding. Excrements of human is flooding through the whole settlements. It's polluting. where like children are playing, bringing huge impacts of diseases. And that's a small example, but and I think then future massive threats coming, and there's not much investment in going into targeting, particularly those areas which are really the hotspots. Sorry, that's my angle.
I would like to comment on that. Just saying that in the urban center database that we were providing, I think a couple of years ago, there are several variables that actually talks about environmental injustice or equity. For example, the access to green, so the amount of open green space per capita in the city, if the amount of built-up surface per capita, so how much you are crowding in your apartments, the air quality, and many other indicators that are actually very much polarized of rich versus poor or versus equal or unequal distribution of environmental characteristic of the people where you live. So if your PM2.5, it's sky, the concentration of pollution is very high, you are living there every day. So that's directly impacting in your way of living in the place. So to the question, I would say yes, there are already some data available. You can go and download, for example, this data set talking about all the what we call cities that are with more than 50,000 inhabitants. But of course, a lot of work must be done still. But even from those very rudimental numbers, you already see quite easily stories of environmental equity or injustice there. So I would say, I would answer yes, it's already possible to talk about that.
Yeah, thank you, Martina, for providing also your view on this. Unfortunately, here there are still a few questions, but time is really running out. So I wanted just maybe to give final word to the panelists if they want to comment. Otherwise, we will be wrapping up the session, as probably many of us want to also to join out the remaining session of the day. Martino, would you like to say anything?
No, I see only there are questions about how we generate population grids, but in very short, we use the built-up areas as a spatial driver it's a top-down approach, mostly top-down. So we start from the census data that are assessed in polygons, and then we downscale those polygons to the grids using the buildings as a spatial driver. So in very short, we put the people in the buildings. That's our, it's very simple model.
Thank you.
We like simple ideas, and that's what we do globally with the same equations, so no discussion on 100 of parameters or millions of parameters. Okay. It's just one parameter.
Thank you very much. I think I encourage everybody who has technical questions to reach out to us and also to provide comments and feedback offline. We are starting now the process of rewriting for the plan for the future. So any comment is welcome. And I think we start. I would like to thank very much the panelists for the contributions and the question and the attendees for the questions. And I think we have to now to close the session. So thank you very much again, and have a nice evening. Bye bye.
Thanks to you, Daniele, for hosting.
Thanks.